When replacing underground conduit, particularly in situations involving lighting poles, it's essential to adhere to best practices for safety and long-term reliability. The situation presented involves replacing damaged underground conduit between two lighting poles. The proposed solution is to use new galvanized conduit with threaded couplings and Ericsson couplings. The question arises regarding the acceptability of using a threadless coupling on the final piece due to difficulty in removing the old conduit from the existing threaded coupling near the base of the lighting pole. The recommendation is that threadless couplings should not be used in this situation. Threaded couplings provide a more secure and reliable connection compared to threadless couplings. Over time, threadless couplings can loosen, potentially leading to electrical and safety hazards. The preferred method is to remove the existing conduit from the threaded coupling at the base of the lighting pole. This process may require a few steps. Firstly, carefully assess the situation to understand how the old conduit is connected and any potential obstructions. Secondly, using a hacksaw or grinder, carefully cut the old conduit. Exercise caution to avoid damaging the existing threaded coupling or the lighting pole base. Thirdly, once the conduit is cut, use a coupling puller to extract the remaining pieces from the threaded coupling. A coupling puller is a specialized tool designed to grip and remove stubborn couplings without damaging the threads. Fourthly, inspect the threads of the existing coupling for any damage or corrosion. If the threads are damaged, consider replacing the entire coupling. Fifthly, clean the threads thoroughly using a wire brush to remove any debris or corrosion. This will ensure a good connection with the new conduit. Sixthly, apply pipe sealant or Teflon tape to the threads of the new conduit before connecting it to the existing threaded coupling. This will create a watertight seal and prevent moisture from entering the conduit. Seventhly, tighten the connection securely using a pipe wrench. Avoid over-tightening, which can damage the threads. Eighthly, after connecting the new conduit, inspect the connection for any signs of leaks or loose fittings. Ninthly, backfill the trench with suitable material, ensuring that the conduit is properly supported and protected from damage. Tenthly, document the entire process, including any challenges encountered and solutions implemented. This documentation can be helpful for future maintenance or repairs. When working with electrical conduit, safety is paramount. Firstly, always disconnect the power supply to the lighting circuit before commencing any work. Secondly, wear appropriate personal protective equipment, including safety glasses, gloves, and a hard hat. Thirdly, use insulated tools to prevent electrical shock. Fourthly, be aware of underground utilities and avoid digging in areas where they may be present. Fifthly, follow all applicable electrical codes and regulations. In addition to using threaded couplings, consider using Ericsson couplings for added protection against corrosion and moisture. Ericsson couplings are designed to provide a watertight seal and are particularly useful in underground applications. When selecting conduit, ensure that it is suitable for underground use and is resistant to corrosion. Galvanized steel conduit is a common choice for underground applications due to its durability and resistance to corrosion. When installing underground conduit, it is important to maintain proper spacing and depth. This will help prevent damage from digging or other activities. The National Electrical Code or NEC provides guidelines for conduit spacing and depth. Consult the NEC for specific requirements in your area. When making bends in conduit, use a conduit bender to avoid kinking or damaging the conduit. Kinks and damage can reduce the conduit's capacity and affect its ability to protect the electrical conductors. After installing the conduit, pull the electrical conductors through the conduit using a fish tape or conduit snake. Be careful not to damage the conductors during the pulling process. Use a lubricant specifically designed for pulling electrical conductors to reduce friction and make the pulling process easier. After pulling the conductors, terminate them properly at the lighting poles and the power source. Ensure that all connections are secure and properly insulated. Test the circuit after installation to ensure that it is working properly and that there are no faults. Use a multimeter or other testing equipment to verify the voltage, current, and continuity of the circuit. Finally, label the conduit and the associated electrical equipment to identify the circuit and its purpose. This will help prevent confusion during future maintenance or repairs. Remember that working with electricity can be dangerous. If you are not comfortable working with electrical equipment, hire a qualified electrician to perform the work. Adhering to these guidelines will ensure a safe and reliable installation of underground conduit for lighting poles. Firstly, always prioritize safety when working with electrical systems. Secondly, use high-quality materials and components. Thirdly, follow best practices for installation and maintenance. Fourthly, consult with a qualified electrician if you have any questions or concerns. Proper installation and maintenance of underground conduit are essential for the reliable operation of lighting systems and the safety of personnel. Firstly, ensure proper grounding of the conduit system to provide a path for fault currents. Secondly, use grounding bushings and bonding jumpers to connect the conduit to the grounding electrode system. Thirdly, inspect the conduit system regularly for signs of damage or corrosion. Fourthly, repair any damage promptly to prevent further deterioration. Fifthly, keep the area around the conduit clear of debris and obstructions. Sixthly, protect the conduit from physical damage from vehicles or other equipment. Seventhly, consider using concrete encasement for added protection in high traffic areas. Eighthly, use corrosion-resistant coatings or wraps to extend the life of the conduit. Ninthly, implement a regular maintenance schedule to inspect and test the conduit system. Tenthly, document all maintenance activities and repairs for future reference. By following these guidelines, you can ensure the long-term reliability and safety of your underground conduit system. Firstly, select the appropriate type of conduit for the specific application. Secondly, consider the environmental conditions and potential hazards when choosing conduit materials. Thirdly, use proper installation techniques to ensure secure and watertight connection. Fourthly, protect the conduit from physical damage and corrosion. Fifthly, implement a regular maintenance schedule to inspect and test the conduit system. Sixthly, consult with a qualified electrician for any questions or concerns. Seventhly, adhere to all applicable electrical codes and regulations. Eighthly, use appropriate safety equipment and procedures when working with electrical systems. Ninthly, document all work performed in the conduit system. Tenthly, train personnel on proper installation and maintenance procedures. Effective training can improve the quality of work and reduce the risk of accidents. It is essential to train personnel in the correct procedures for installing, maintaining, and repairing underground conduit systems. Training should include topics such as safety procedures, proper use of tools and equipment, conduit bending techniques, and troubleshooting common problems. Regular training updates can help keep personnel up to date on the latest techniques and best practices. In conclusion, replacing underground conduit requires careful planning, proper techniques, and adherence to safety guidelines. Firstly, prioritize safety at all times. Secondly, use high-quality materials and components. Thirdly, follow best practices for installation and maintenance. Fourthly, consult with a qualified electrician for any questions or concerns. By following these steps, you can ensure a safe and reliable installation that will provide years of trouble-free service. When dealing with electrical systems, it's always best to err on the side of caution. If you're unsure about any aspect of the installation, consult with a qualified electrician. Their expertise can help ensure that the job is done safely and correctly. Furthermore, consider the long-term costs and benefits of different conduit materials and installation methods. While some options may be more expensive upfront, they may offer better durability and require less maintenance over time. This can save you money in the long run. Proper planning and careful execution are essential for a successful underground conduit replacement project. Consider the impact of the work on surrounding areas and take steps to minimize disruption. Communicate with stakeholders and obtain any necessary permits or approvals before starting the work. By taking a proactive approach, you can avoid potential problems and ensure a smooth and efficient project. The NEC, specifically Article 300, provides detailed requirements for wiring methods, including underground installations. Refer to the NEC for specific requirements in your area. such as burial depths, conductor types, and grounding requirements. Failure to comply with the NEC can result in fines, delays, and potential safety hazards. Also remember to consult local codes which may have additional or superseding requirements. Consider the environmental conditions when selecting conduit materials and installation methods. In areas with high levels of moisture or corrosive soils, it may be necessary to use special types of conduit or protective coatings. Proper selection of materials can help extend the life of the conduit system and prevent premature failure. After completing the conduit installation, it's important to perform thorough testing to ensure that the system is working properly. Testing should include visual inspection, continuity testing, and installation resistance testing. Any problems identified during testing should be corrected before energizing the circuit. Document all testing results and keep them on file for future reference. Proper documentation can be helpful for troubleshooting and maintenance. Remember that underground conduit systems are often subject to harsh environmental conditions. Regular inspection and maintenance are essential to ensure the long-term reliability of the system. Inspection should include checking for signs of damage, corrosion, and water intrusion. Any problems identified during inspection should be addressed promptly. Regular maintenance can help prevent costly repairs and ensure the safety of the electrical system. When working with underground conduit systems, it's important to be aware of potential hazards. These hazards can include buried utilities, contaminated soil, and confined spaces. Take appropriate precautions to protect yourself and others from these hazards. Follow all applicable safety regulations and use appropriate personal protective equipment. Safety should always be the top priority when working with electrical systems. If you encounter any unexpected problems during the conduit replacement project, don't hesitate to seek assistance from a qualified electrician or engineer. Their expertise can help you troubleshoot the problem and find a safe and effective solution. Remember that electrical systems can be complex and dangerous. It's always best to seek professional help when you're unsure about something. Continuing on the topic of safety when working with underground conduits, one must never forget that the underground environment might contain not only electrical cables but also gas pipes, water pipes, fiber optic cables, and of course the ground might be unstable, so proceed with extreme caution. Firstly, it's advisable to perform a ground-penetrating radar scan before starting any excavation, especially if the site history is unknown. Secondly, always contact local authorities to mark the location of underground utilities. Thirdly, use non-sparking tools whenever possible, particularly near gas pipes. Fourthly, implement proper shoring techniques to prevent cave-ins. Fifthly, ensure proper ventilation in confined spaces to avoid the accumulation of hazardous gases. Sixthly, wear appropriate personal protective equipment, including respirators if necessary. Seventhly, have a safety plan in place and communicate it to all workers. Eighthly, designate a competent person to oversee safety on the job site. Ninthly, conduct regular safety meetings to discuss potential hazards and best practices. Tenthly, document all safety procedures and incidents. Also, never assume that the conduit is empty. It might contain abandoned cables that are still energized. Use a cable locator to verify that the conduit is de-energized before cutting or removing it. Even if the conduit is de-energized, treat it as if it's energized until you have confirmed otherwise. Furthermore, when working with electrical conductors, be aware of the potential for arc flash. Arc flash is a dangerous electrical explosion that can cause serious burns and injuries. Wear appropriate arc-rated clothing and personal protective equipment to protect yourself from arc flash hazards. Follow all applicable arc flash safety regulations and procedures. Finally, never work alone. Always have someone nearby who can provide assistance in case of an emergency. Working alone can be dangerous, especially when working with electrical systems. Having a second person present can help ensure your safety and the safety of others. In conclusion, safety should always be the top priority when working with underground conduit systems. Take appropriate precautions to protect yourself and others from potential hazards. Follow all applicable safety regulations and use appropriate personal protective equipment. If you're unsure about something, seek assistance from a qualified electrician or engineer.